Welcome to the bonus video of the MOJO project. This video is about the origin of the interstellar object Oumuamua. Now, Oumuamua is the first object that we found passing through our solar system. It came from outside, from interstellar space, passed very close to the sun inside the orbit of Mercury, and now is on its way back out. And as you can see in this image, the orbits of the planets are shown in blue, and the trajectory of Oumuamua is shown in the dashed line. And you can see it comes from kind of above the plane of the planets, passed close to the sun, and now it is on its way out. And it's moving so fast that we can't explain its speed, as part of the solar system. So it really definitely came from exterior to the solar system. Now here's what we know about Oumuamua. We can measure its brightness and see how its brightness changes in time. And we see that it goes up and down quite a bit with kind of following a regular pattern. And it goes up and down quite a bit. So much that we think it has a very stretched out cigar-like shape. Even though we don't see that shape directly, we just measure the brightness variations, we think it must be very stretched out like that, and in this tumbling rotation. We can also measure its colors, and it looks a lot like a comet in terms of its appearance, or at least a volatile, rich solar system body like a water-rich asteroid. But it didn't behave like a comet when it passed close to the sun. It passed very close, but there was no visible outgassing or activity. So it didn't create a coma, it didn't have any tails like comets do when they pass close to the sun. So this kind of combination of looking like a comet but not behaving like one is one of the mysterious aspects of this object. Now the MOJO project's contribution here has been to develop a model for the origin of this object. And we think that it might be a fragment, a piece of a planetesimal that was a comet-like planetesimal that was kicked out of its solar system by a giant planet, and now we're seeing it passing through our own solar system. So let me explain. So as we've talked about in other videos, we think that planetesimals form in disks around young stars. There's not enough stuff in between stars to form these large objects, so they have to form in the dense region of a planet-forming disk. Okay? But we've seen objects from interstellar space now, so how do they get from their disks into interstellar space? They need some kind of kick. And we think that giant planets, Neptune-to Jupiter-mass giant planets, provide the gravitational kick necessary to eject planetesimals from their home planetary systems out into interstellar space. Now, we've run simulations of this process, and it's very efficient. And we've noticed something interesting. So on the path to being ejected, a small fraction of planetesimals, about 1%, passed really, really close to a giant planet. So close that they should have been tidally disrupted, torn into pieces by the gravity of the planet. And this may sound like an abstract idea, but we have examples of it happening in our own solar system. In 1992, comet Shoemaker-Levy passed so close to Jupiter that it was torn into a long string of small pieces. And you can see that in the image right here. These are images of those pieces. And so we know this process happens, and our simulations indicate that it happens a lot when giant planets eject planetesimals. And there's one more piece of the story here. So our simulations show that a small fraction of planetesimals get torn to pieces by giant planets before they get ejected, but those pieces are not immediately thrown out into interstellar space. Instead, they still pass close to their star a few times, 10 times, 100 times, 1,000 times. Most of those pieces pass close to their star enough times that they should actually lose their surface volatiles and become extinct. Models of how comets in the solar system evolve show that they only have a certain number of passages close to the sun before they lose all of the ices on their surface and they stop outgassing, they stop being active. And they don't just disappear, but they're no longer active, they're extinct. And most of the fragments of planetesimals, after they're torn to pieces, those fragments become extinct before they're launched into interstellar space. So, putting the pieces together, we think that Oumuamua is a fragment of a comet-like planetesimal that was rendered extinct before it was ejected. And if that's the case, it can explain why Oumuamua has comet-like appearance, but doesn't behave like a comet, because it's extinct. And its close encounter with a giant planet that being torn into pieces may explain why it has this stretched out shape and this strange tumbling rotation. So to summarize, our origin story for Oumuamua, we think its parent body, a planetesimal, formed in a disk around a young star. That planetesimal passed too close to a giant planet, maybe a Neptune-like planet, maybe a Jupiter-like planet, and was torn to many, many pieces. Those pieces passed close to their star several times before being ejected, enough times to lose their surface volatiles and become extinct. And then finally, they were ejected. Oumuamua was ejected into interstellar space, eventually passing through our solar system where we see it now.
MOJO.